Welcome you all to the week 1 problem solving session of Basic Calculus 1. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical systems. This particular week 1 is devoted to the real line, absolute value and functions. So before starting with the problems, I would like to recall some notations, then we will focus on our problems. So these are some basic notations. First of all, this phi set is denoted for the empty set. While to denote the set of natural numbers, that is defined from 1, 2, 3 and so on, this is the set of natural numbers. One can observe here that we are not writing it as normal n. We are writing it as in this particular special kind of notation, which we would like to denote it as a set. So can anybody confirm me that I am audible?
Yes, sir.
Thank you. So next one is the set of integers. So now I'll not write, I just say the set of integers. So this will be minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Okay. Similarly for the rational numbers, we write like this, where P can be n integers and Q belongs to natural number. And the real number, we basically, it is a collection of Q and Q complement. So in the class, you have follow up that this real number can be defined in this two way. First with this, and second is the completeness property. So our focus here is completeness over the completeness property of R. So let me write the first question. Examine whether the infimum and supremum exist and belong to the given set. So first given set is like this, collection of all real numbers such that this x lies between 0 and 1, including 0 and 1. So we have given this set. We have to decide whether its infimum and supremum exist, and moreover to that, whether it is belonging to the set or does not belong to the set. So before going to this solution, let us first recall that what is this infimum and supremum. Although it has been already done in the class, so let me just quickly recall. So definition. Let A be. So here we are already using A, so I'm writing it S. S be any non-empty subset of R. Then real number u is called an upper bound of S if and only if each, or let me write it in a mathematical way, if and only if S is less than equal to U for all S in S. That means this U is greater than all the elements of our given set S. While next one says that this is the, you can say, first point. Second point tells us what is the least upper bound, that is supremum. So an upper bound L of S is called a least upper bound or supremum of S if and only if it is lowest of the, if and only if L is less than equal to U for all U. So in all the upper bounds, it is the least one. In the same way, you may define the infimum, or you can say greatest lower bound. So what will be the change in case of infimum? I am just mentioning the inequality. In the case of infimum, suppose I am talking about V is the lower bound of S. So that means if and only if V must be less than equal to S for all S in S. Next one is greatest upper bound, or you can say infimum. So greatest, then that means some G. So it will be greatest lower bound if and only if it is greatest of all those lower bounds. So this is the mathematical way to write this definition. Now let us apply this to the given example. We have given this set for all x belongs to R. X must lie between 0 and 1. So if you will write it in interval form, this will be nothing but closed interval 0 and 1. So if you will draw on number line, so this is your 0 and this is your 1. So this is your interval, this whole. So what can be the upper bound of this interval? Or you can say upper bound of the set A. It can be 2, it can be 3, it can be 4, it can be anything. But what will be the least upper bound of this, all of these? The least upper bound will be, or you can say supremum of A will be 1, because it is the least one out of all these upper bounds. In the same way, if you will look at lower bound of A, lower bound will be 0, -1, -2, and so on in the decreasing way. So then greatest lower bound or you can say infimum of A will be, which number is the greatest out of these? 0, -1, -2, -3. The greatest one will be
My
0. 0.
0.
Yeah. So here you are
Yes,
able
sir.
to easily decide this is your infimum is 0 and your supremum is 1. Now what is our second question, that whether it belongs to the given set or not. Yes, Matt?
So the thing is that 0 and 1 is included in the set itself, right?
Yes.
Then why, like, it's okay if it's inside the set, we can take them as infimum and supremum.
Yes.
Okay, thank you.
That is what written here, na? That it should be less than or equal to. So
Yeah,
either it has to be equal or it has to be greater than that all the elements. Okay.
okay.
That is why we are also asking here whether it should belong to the set, the existing infimum or supremum is belonging to the set or not. Okay. So here the conclusion is it belongs to our set. So you will get a better understanding in the second one. Next is collection of all those real numbers such that x lies between 0 and 1. Here 0 is excluded and 1 is included. Now you can try this one with the above definition and let me know whether infimum and supremum is existing. Furthermore, it is belonging to the set or not. So simultaneously, let me write two more, then we will discuss them. Second one is set of integers and any subset b dash, that is all those integers such that -4, this one, and the last one is d.
Try all of them. I hope it will find now. So try all of them. Then we will discuss. Did anyone get anything? So let us I'll write this again. So for this set C, again, if you write it in an interval form, then this will be open 0 and closed 1. So this 0 and this is 1. So this 1 is included and this 0 is not included. It's called interval. So what will be the upper bounds of C? Will be 1, 2, 3 and so on. So let me write it in the form of this. And least upper bound of C out of these will be 1 again, and this will belongs to the set C. When you will talk about lower bound of C, so lower bound will be 0, -1, -2 and so on. And out of this greatest lower bound, and it is also called its supremum and it's called infimum of C will be 0. But here 0 belongs to the set or not?
No, sir, it doesn't.
So it does not belongs to the given set. So every time it is not possible that our infimum or supremum should belong to the given set or not. So here also let me write it. So next one is part the set B integers, while B dash is equal to all those integers such that -4 less than x less than 4. So what will be the case of this B? Can you guess what will be its in fact upper bound? Is integers bounded? Can you bound integer with any number, any real number? See here, bounded by a number means existing real number. We are not talking about infinity. We are talking about any finite number. So Z in fact has no upper bound and no lower bound. Thus, you can say Z is unbounded above and also unbounded below. Why? If you will guess any number, for example, you will say Z is bounded by 2, bounded above by 2, then one can give you the number 3. So 3 will be the upper bound again. Again, if you will say 100, then there will be existing a number 101. So you cannot decide any upper bound of this Z. Thus, this is unbounded above and also unbounded below. And moreover to that, what we can say, Z has no finite supremum as well as no finite infimum. What will be about this is some b we are denoting, or in fact you can keep it at z also. What about b dash? Is b dash is bounded above and bounded below? Can we write b dash in some set form? This is the collection of all those integers that lies between -4 and 4, including both the integers. So first one will be -4, second integer will be -3,
-3.
-2, -1, 0, 1, 2, 3 and 4. Since it's a discrete set, you can clearly tell what will be the upper bound of this b dash. 4, 5, 6 and so on. Again, what will be supremum of this b dash?
4.
Whether it is belonging to the set?
Yes, sir.
Yes, sir.
Yes, sir.
Next, what will be lower bound of b dash?
-4.
-5, -6. It can be anything. And but infimum will be
-4.
next.
Sir,
Yes.
can upper bounds of B dash be real numbers like 4.5?
Can you repeat your question?
Sir, upper bounds of B dash can be 4.5, like 4.5, 4.7,
yes.
like real numbers.
Yes. It is in fact
Okay.
this upper bound and lower bound is defined for any real number. Here, see here. A real number u is an upper bound. We talk about real number. You will understand in the example number D. D, collection of all those rational number such that less than under root 3. So here you cannot write in an interval form. If you want to write in an interval form, then you have to collect only the rational numbers. So what can be the upper bound? Simplest upper bound. Upper bound of D will be root 3 to infinity. Any element, any real number. Am I right? Any doubt?
No, sir.
So what is the definition of upper bound? We want our element x to be less than equal to u for all x. Okay, so here this is the collection of all those rational numbers that are less than under root 3. So I am saying that you collect all those upper bounds that are above than under root 3, then obviously every element of D will be less than this. Then what will be the supremum of D? Out of these all upper bounds, which is the least upper bound? Under root
3.
So it is a real number. I hope Archit it is clear now.
Yes, sir.
It is a real number. Now tell me whether it is belonging to the set or not.
No, sir.
Why?
No, sir.
Why?
Sir, because it's an open interval, sir. Root 3 is not included in the set.
Suppose I am including, then
Sir, then it will belong to the set. No, sir. No, sir. Then as it is x
It is
belongs to
rational
rational
number.
number, then
No.
also it will not belong.
Why?
Sir, because you are taking rational numbers only, na?
Rational
X
number.
belongs to rational.
And root under root 3 is an irrational number. And that is why also in class sir told that Q does not follow completeness property. What is completeness property? Anyone? What is completeness property? Check your notes and try to recall. What is completeness property?
Sir, for any given subset of R, there exists a least upper bound and a least lower bound.
Are you sure? I don't think so.
Sir, I recall this.
Every non-empty subset of R that has an upper bound, it must have a least upper bound in that set itself. Okay. First of all, priority condition is you must have an upper bound. Then you can guarantee about the existence of least upper bound if that set follows the completeness property. Here what is happening? You have an upper bound under root 3. In fact, more than all the numbers are upper bounds of this set. But it has a least upper bound. It does not belongs to the set. So it is not belonging to the set. That means we got a set which has an upper bound, but its supremum does not belongs to itself. That is why it is not following the completeness property. Any doubt? If you had, you can ask. Shall
Sir,
I?
like the definition goes, in case of real numbers, you take the upper bounds as real. So in case of rational numbers, why can't we take only rational numbers as upper bounds?
See, the definition is defined in that manner only that you talk about upper bound, this upper bound and least upper bound for real number. You are treating it as a real number. This is predefined. Okay.
Yes, sir.
So let us move to the next one.
Sir, sir, how can we showcase that the Q is an ordered field that is not complete?
Q is an ordered field that is not
Complete.
in the same
Because
way.
when we are discussing about order completeness property of real numbers, there also we mentioned this every non-empty subset of real numbers that is bounded above has a least upper bound. So why not with this Q? Q is an ordered field that is
Yes,
not complete.
yes, it is not complete.
How can we show this?
This example is itself showing that thing that you were asking. It has a
If
supremum.
we have to take some other example related to this only, how can we show? How can we
See,
prove this?
see.
Hmm.
There are two things. If you want to prove some statement, then you have to prove it thoroughly. Okay. If you want to disprove it, you need only one counter example that is sufficient. Okay.
Okay.
In the
Yeah.
same way, you can construct many counter examples. In general, if I would write, for example, any set of rational numbers such that it is less than q, where q is nothing but an irrational number. Whenever you will take this kind of set now, these kind of sets does not follow the completeness property, because
Okay.
supremum anyway is going to be this q, and q is an irrational number which does not belong to the set. Okay. So
Okay.
one thing left in this particular example, what will be the lower bound or infimum?
So it will be not defined.
Not defined. So
Yes, sir.
Yeah. It was
no
not defined.
finite infimum of d exists. Okay. Now one simple example, or you can say exercise. Write the decimal representation of 1 by 9. Can we get the rational number from its decimal representation? Tell me how you will recognize this rational number in form of decimal, if I want to say, because there are various kind of decimal representation. Three kind of, I mean. One is
Sir,
hmm, say.
sir, sir, if it terminates or it is recurring, then it is rational. Or if it does not terminates non-recur, then it is irrational.
Good. So here decimal I am saying, can we get the rational number from the decimal representation? Means we are talking about terminating or non-terminating but repeating kind of decimal representations. So there are three kind of this decimal representation. One is terminating. Terminating means, for example, 1.5, 2.25 and so on. Here terminating non-terminating but repeating. So in this scenario, what will be the example? 0.111, 0.2323 and so on. And the last one is non-terminating and also non-repeating. So the first two case fall under the category of rational number, and this last one is irrational number. Okay. So what will be the decimal representation of 1 by 9? Anyone?
0.111, and so it goes on.
0.11.
Do have anyone have doubt in this? What the decimal representation of this 1 by 9?
No, sir.
So it is obvious, when you will divide, it goes on repeating. So for short, we may write bar over this because 1 is repeating itself. In case of 0.2323, we will write 0.23 bar. Okay. So this is the decimal representation of this 1 by 9. Can you write, can you get from this decimal representation to the original rational number? Can you do it?
Yes.
How? How, Hariom?
Sir, actually, I don't know the name of the method, but we
It's
can
fine.
do it.
You can tell me the approach. So anyone else?
Sir, may I?
Yes, please.
Sir, we will take a variable, let's say x equals to 0.1 bar and multiply both sides by 10.
Okay.
Then we'll get 10x equals to 1.11111.
Okay.
Then we will subtract the first equation from second.
Okay. So let me tell others also. So suppose we are saying that this let x equal to this 0.1 bar. That means 0.111 and so on. When we'll multiply with this 10, then it will be 1.1111. Can we write it as 1 plus 0.11? This is nothing but again x as you let. So 10x will be 1 plus x. So that means 10x minus x will be 1, 9x will be 1, then x will be 1 by 9. So that means you got 0.1 decimal representation is nothing but 1 by 9. Is it clear? If you have any query, you can ask me in between. Okay. So
Okay.
next one is, let us move to some interval kind of problems. So if your x lies between 2 to 6, then which of the following statements about x are necessarily true? The first one is, you have given x lies between 0 to 4. Is this true in this scenario? I hope you
Yes.
understood the question.
Yes, sir.
Yes, sir.
So in this case it is true. Why? If you will draw, your x lies any number. Suppose this is 0, or let me write it like this. Suppose this is 0, this is 2, and this is 6. So your interval that you have asked is this one, but with open sign. Okay. But in the A option, what we have given, all those x that lies between 0 and 4. So in this scenario, I'm drawing it with this red one. So this is the collection of all those, this one. Now tell me whether it is true.
No, sir.
No, no.
Someone
No,
is
sir.
saying yes earlier.
No, sir.
So this will not be true. Now in the same way, tell me about this. If x minus 2 lies between 0 to 4. Now tell me about this one.
We'll
Yes,
have
sir.
to solve the
True, sir.
inequality first.
So if you will
True,
solve it,
sir.
what you can do, you can add 2 on these inequalities or equation. So 0 plus 2 less than x minus 2 plus 2 less than 4 plus 2. Does it make any effect in the previous equation and this equation?
No, sir. Answer is C.
No, sir.
So no effect, because this follow the order of some properties that you have learned from the class. You will get 2 less than x less than 6. It is the same, I guess, that we have given in the starting. So this will not false. Next one is 1 by 6 less than 1 by x less than 1 by 3. What will be the scenario in this case?
Multiply 3 by both sides, I guess.
I am doing what you are saying only. So this will be, what will affect then? See, you have to compare the range of x. So here,
Yeah.
if you will
True.
observe that here your x lies in the denominator, what do you have to do? You have to reciprocal it.
Reverse it.
Reciprocal.
Yes.
Yes, sir.
So in case of reciprocal, if you remember, these all are positive numbers.
Yes, sir.
Yes.
So in case of reciprocal, inequality will reverse. Okay. When you will
Yes.
reciprocate it, so it will be 1 by 3, that is nothing but 3 less than x less than 6. Anybody has any doubt in this inequality that I wrote here? Good enough. So here it is the collection of 2 to 6. Here it is the collection of 3 to 6. So is they making any disruption between two statements?
No.
Sir, it
No,
should
sir.
still be true.
Okay. Now tell me the last one. Minus 6 less than x less than 2. What will be in this scenario?
Not true.
Reason?
Because it's not included in the set
If you
itself.
will draw here, this will be, suppose some minus 6 is here, so this will be minus 6 to 2. So this is exactly the complement, you can say, out of the this given interval 2 to 6. Okay. So till
Yes.
now you got understanding of supremum and infimum, decimal representation, and this somewhat interval flavor. Next we discuss about absolute value function. So find all those x which satisfies the a part is 3 minus 1 by x mod is less than half, b part is 3r by 5 minus 1 greater than 2 by 5. So here please keep the caution that here it is 1 by x, not x. Try these two, then we will discuss it. Did anyone get anything?
Sir, in first x belongs to pi.
X belongs to?
Phi said no real number exists.
Okay. Any other? So before going to this solution of this, let me first recall what is this mod of x. Mod of x is defined like this: x minus x when it is positive, and minus x when it is negative. So overall, what is doing mod? Mod is just giving you the output as positive number. If it is positive number, then it will not do anything to it. But if it is the negative number, then it will give you positive number. So if I would say here mod x is less than equal to a, then what you can say? You can say x is less than equal to a and minus x is also less than equal to a. Why? Because the definition of mod x, what say? Definition of mod x will give x when x is positive, and it will give you minus x when x is negative. So here you are not aware about it is whether x is positive or not, but mod x is anyway positive. So that means x will also greater than or less than equal to a, and minus x will also less than equal to a. And if you will combine it, and when you multiply both the sides with minus sign, the inequality will change, and on combining them you will get minus a less than equal to x less than equal to a. In the same way, if I would ask you mod x is greater than equal to a, what you can say by definition? Similar to the above, tell me by definition. Anyone?
The negative condition won't exist for this one.
We will discuss it further. Just tell me about this mod x is greater than equal to a. What can you say?
In the first line, we write x is greater than or equal to a, and minus x is greater than or equal to a. And then for the right hand side, like this, the first situation will remain as it is. And for the second one, x will be less than or equal to minus a.
Fair enough. So you recalled how the mod is being or can be utilized. So the same we'll do in our given question. So for A part, what you have given? 3 minus 1 by x is less than half. The one way is you write 3 minus 1 by x is less than half, and also negative sign of this 3 minus 1 by x is also less than half. One way is this. One way is the above that we have discussed here. If mod x is less than equal to a, you can say x will lie between minus a to plus a. So if you write with this, so minus half less than 3 minus 1 by x. I hope here there will be no confusion, because here we are talking about less than equal to a, and here it is strict inequality. I hope there is no confusion regarding that. See, less than equal to means it is less than or it might be equal. Okay, so less than relation still holds. So we follow up this one. Here it is 3, so you will add minus 3 on whole the inequality. What it will give? Is it correct? Next, what you can do? All are the
Sir,
negative sign. You will
we can
multiply.
remove, cancel them. Yes, sir.
So you will multiply with
Minus 1, sir.
7 by 2. Here it was, sorry, it was 1 by x. Now again, x in the denominator. So you need x to be in the numerator. What you will do? You will reciprocal all the whole the equation. So it will give you 2 by 7. Any doubt?
No, sir.
I guess someone is saying that no real number exists, but here it do.
Yes, sir, I have done a mistake in the sign of inequality in the last step.
Okay. Any doubt? What about the B part? 3r by 5 minus 1 is greater than 2 by 5. Try this one in the same way. Again, no real number existing or any other answer?
So existing, sir, minus infinite to 1, open bracket, union 7 by 3 to infinite, open brackets.
Okay. So mod x is greater than a. So that means 3r by 5 minus 1 is greater than 2 by 5, as well as 1 minus 3r by 5 must be greater than 2 by 5. So from this first one you will get 3r by 5 is greater than 2 by 5 plus 1. This will give you 3r by 5 is greater than 7 by 5 and r is greater than 7 by 3. In the same way, you will get here 1 minus 3r by 5 is greater than minus 3 by 5. Next is both side you have negative number. If you will divide with minus 1, so it will be inequality will be reversed and you can conclude that r will be less than 1. So Archit, you have same answer or something different?
Sir, it's same answer, sir. And but sir, in my answer, sir, it's not end, sir. I have used odd.
No, it should be and. Or means union.
Yeah,
Sir, I
that's
have
just
a doubt. Why did we, like in the second one, why did we take it reverse? Like, why did we write 1 minus 3? Like, I didn't get it.
See here, if mod x is greater than equal to a, that means either x greater than equal to a or minus x, both have
Yeah.
to greater than equal to a, right?
Yes.
If both things have to greater than equal to a, that
Hmm.
means
Oh,
this
that
number,
means A will come first. Yeah.
understood?
Yeah, I got it. Got it.
Sir, if we use and, then in this case we are getting r belongs to 5. But if we see, if we take r equals to 0, that will satisfy.
So
So sir, I think sir it should be odd, sir.
anyone?
It should be and only, sir, because like it is a part of a mod itself. Mod is
Third
either
opinion.
minus
Wait,
plus.
man. Third opinion.
Sir, it should be union.
No, and or.
Or
Okay. Achha, tell me, I'm giving you a real number. So can it be both positive negative at the same time?
No, sir.
No. Then how is this possible?
So like if we take a simple example like mod x greater than 5 and we solve it in your approach, then we will get no result. But if we think logically, if mod x is greater than 5, we have infinite answers.
So you have to think about it. Whether it is and, it should be and, or it should be or. You have attended the class? Have you attended the
Sir, I
class?
have attended. Yes, sir, I have attended the initial classes, not all the classes.
So it's in the, I think, third or fourth class. Just a second, please. So here, let me first conclude it. This will be your final. So here and means not that and that you were saying, not intersection, not intersection. Here and means just, you can say, meaning that R can be this and R can be this. Okay, I am not saying here that it should lie in the both intervals. Are you getting it?
Yes, sir.
So you solve with this one, supposing that your mod x is positive, and you follow this one when you are assuming that your x is a negative number. So x can be, or you can say here r, so r can be either more than 7 by 3 or it can be either less than 1. Okay, so here and means not that union or intersection stands for. I'm following both the case. It can be possible that, it can be possible this. While if you talk about this one here, if you will solve it explicitly, what will you get? Let us do it here also. When you will solve this one, what you will get? 3 minus half is less than 1 by x. So 1 by x will be greater than 5 by 2 and x must be less than 2 by 5. And when you will follow this one, you will get 3 minus 1 by x is greater than minus half. Then 3 plus half will be greater than 1 by x, and 1 by x will be less than 7 by 2, and x must be greater than 2 by 7. Okay, so again I am saying here and doesn't mean that you are asking, it is not standing for the intersection interval. It is standing that it can be follow this case or it can be follow this one case. Okay, now the next one, find all those, yes, such that x square minus x is less than 0. Try this one. A similar question has been done in the class. I'm just recalling it. So everybody, first of all, focus here. Let me tell you this mod x less than equal to a and mod x greater than equal to a with some another scenario. What is mod x actually? What this mod x represent, physical interpretation of this mod x? Anybody?
Sir, it basically represents the distance from number line.
Okay.
So distance of a point from the origin.
Yes. So mod x is nothing but distance of x from 0. Origin means 0 in a real number. So if I am saying mod x is less than equal to a, that means distance of x from 0 can be at most a, correct?
Yes.
So
Yes, sir.
in number line, how it will look like? Suppose this is origin, this is your a, this is your minus a. So this is a bounded distance. You are telling that it should be lie in this number, in these two numbers, right? This distance is a and this distance is also a, correct?
Yes.
So whether your x fall here or whether your x fall here, it has to be combined, correct?
Yeah.
Because it is a bounded region. But if you will talk about mod x greater than equal to a, then what does that mean?
Sir, we are considering the positive distance. I mean, sir, positive number.
Distance of x from 0 is at least a.
A.
So that means if this is your a, this is your origin, this is your minus a, so that means either it will fall here or it will fall here. This is an unbounded region. In this case scenario, you will say you have to take either this case or this case, while in the above you have to combine them. So for a sake of simplicity, I am saying if you are kind of the relation given less than equal to a, that means you have a bounded region and you have to combine the inequalities. While if it is greater than equal to a, that means it's an unbounded region. You have to consider any of them. So if you will write it properly mathematically, then here this and should be, although I was saying the meaning is same, either this should be true or that should be true. So this should be or. While if you talk about this less than relation, in that there will be only and. Am I clear? I'm again repeating, in case of less than equal to a, you need to combine both the inequalities. You can see from the geometrical interpretation, I told you that. And in case of if you have mod x is greater than equal to a, that means you need to consider any of the cases. In those cases, you have to see whether one is true and another one is true. So you have to take the union. So this is about this mod clarity. Now let us discuss the next one. So how you will do this one? Anyone?
By complete square method.
So what
We
will
can
be
write
the,
this as x into x minus 1, sir.
so x square, it can be written as 2 into 1 by 2 into x. So I am just recalling what is a plus b whole square. a square plus b square plus 2ab.
2a.
Similarly, a minus b whole square, so a plus a square plus b square minus 2ab. So here it is 2 into 1 by 2 plus x. So here what you need to add? 1 by 2 whole square and subtract the same quantity to make those both the quantities are equal, LHS and RHS. So this will give you is it clear till now? You have given that x square minus x is nothing but less than 0. So it can be written as x minus half square minus this half square. It is less than 0. So a square minus b square is like, how can you write it?
A plus b into a minus b.
So it will be a minus b. So this will give you x into. So in this case scenario, tell me where your x can fall. You have two critical points. Critical
Yes.
points means where sign is going to decide 0 and 1.
1.
So what if your x is greater than 1? Suppose 2. If you will put 2 in this equation, 2 will be a then LHS will be a positive or negative?
Positive.
When you will fall between 0 and 1, suppose 1 by 2, then LHS will be
Negative.
and when you will below the 0, minus 1, minus 1, put minus 1.
Positive.
Clear? So which interval you need it? For which this LHS is negative. So where is your LHS is negative? You are seeing in this number line.
Between
After 1,
0.
sorry,
After 0.
after
When
0
x is greater than 0.
0 to 1.
0 to 1.
Less than 1, sir.
Understood? How you are guessing these intervals? So now we have covered your decimal representation, the supremum and infimum, your interval and absolute value problems. Now the turn of functions. So in case of functions, let us start with the basic one. Find the domain and range of the following functions. The first one is f of u is equal to 1 by 2 plus under root u. What is the domain and range of a function? What is the domain and range of a function?
Real numbers, please.
Not every time it is a real number.
Sir,
Domain,
all the value, all the real number for which it will be defined.
yes,
Yes.
exactly.
Yes, sir.
All those real numbers for which the function is defined. If you will observe here, here is under root u. So inside the under root, only non-negative numbers are allowed. Everybody agree?
Yes.
So that means domain of f will be all those real numbers such that u must be greater than or equal to 0. Okay? Can the denominator will be 0 at any place?
No, sir.
Why?
It will be become infinite.
No, I am saying can the denominator for any value of u can be 0? Nancy, I think you missed the question. I'm asking, is there exist any u for which this f is undefined?
No, sir.
There does not exist any u because root u is itself giving you a positive number, and whenever you I add positive number into, it cannot be converging to 0. Okay, so there does not exist any such number that you have to take care of. For example, if here there will be 1 by x, then you have to take care that x should not be 0. Okay, but here
Yeah.
this will not be the case. Okay, so what will be the domain? 0 to infinity. Range, what will be the range of f? Whenever you have this kind of
Real number.
real number. Okay, how will you get the negative numbers? Tell me that. How will you get 0?
Whole number.
So
No.
0 to 1 by 2. 0
Zero.
open, 1 by 2 close.
0 to 1 by 2. Anyone have any issue in that? See, what is the domain? 0 to infinity, and 0 is included. When you put 0 in this function, what it will give you?
1 by 2.
1 by 2. When you put any number greater than 0, for example 1, what it will give you?
1 by 3.
F of 0 is 1 by 2, f of 1 is 1 by
1 by
3,
3.
3.
f of 2 is 1 by 4. So if you will observe, this range is nothing but decreasing.
1 by 4 तो नहीं होगा मास्टर.
Hariom. So
सर
this,
1 by 4 नहीं होगा.
okay, sorry. 1 by 2 plus under root 2. If you will put 1 4 here, now it is fine. So anyway, the range of s is going to decrease. When your, why I am putting only 1 2 3? If you will observe that domain is 0 to infinity, you can only put 0 or positive real numbers. And when you will close to this infinity, where this function will go? Tell me.
It will become much smaller, sir.
Smaller, near to 0.
Infinitely. Yes.
So that is why I wrote here open 0 and closed 1 by 2, because 1 by 2 can be obtained at u equal to 1, while 0 cannot be obtained. Now you have to do the similar in this function. 1 by under root what will be the domain of this g? First of all, as we have done in the previous one, what we have to make sure our function should be defined for those values of v. Again you are saying seeing under root here. So any quantity inside the under root 2 has to be positive or negative?
Positive, sir.
Positive, or more precisely non-negative, because it can also include 0. Can it include 0 here?
No, sir.
Why?
No, sir.
Sir, 1 by 0 is not defined.
1 by 0 is not defined. In usual case, when you talk about only fx equal to under root x, then you will say domain of f will be 0 to infinity. That means x can be greater than equal to 0. But here it is in the denominator. In the denominator you cannot consider 0. Correct? So it should be exactly greater than 0. Strictly greater than 0. So if it is greater than 0, that means 5 must be greater than v square. Correct? So what you will write from here? Tell me. V square can be written as can we root like this, or the best way around is this one. Take minus sign common. V square minus 5 will be negative. Any problem? Is it clear to everybody what I have done here?
Yes, sir.
A square minus b square, v minus under root 5, v plus under root 5. So what are the critical points here? What are the critical points?
Minus under root 5 plus under root 5.
So after plus under root 5, you are taking any number. Suppose 3. At 3, is LHS is positive or negative? At 3,
Positive.
Positive.
while between minus under root 5 to under root 5, that is, if you put 0, then LHS will be,
Negative.
and when you will put any minus 3 example, for example minus 3,
Positive.
in general there is a sign convention that says you should write plus minus plus. This is a sign convention. I am not following that convention because there is some loops in that also, so I have to tell that also. So I am just avoiding, and I'm saying to just put some values, you will get to know. Now what do you want this product to be? Negative. You want your LHS to be negative. So which interval you will take?
Negative 5 to negative root 5 to root 5.
So what is the domain of your function g? Clear to everybody? What is the range of g? Under root x will give you positive values or non-negative values or negative values. Anyone?
Non-negative values.
Non-negative
Negative.
values.
Positive.
But here it under root x is in the denominator. Can it will give you the 0 value?
No.
No, sir.
So what will be the range? From 0 to open 0 to
Infinity.
infinity. Clear to everybody?
Yes, sir.
Okay. Now you learn about what is the domain and range of function. But if I will give you some graphs, how can you decide that graph is a graph of a belong to a function or it represents any equation? There is a difference of equation and there is a difference between graph of a function. Then you will got to know. Examine whether the following are graphs of a function. The first one is so how will you tell this is a graph of a function or this is not a graph of a function?
Sir, we sir, we can use vertical test, sir.
Vertical line test.
Yes, sir.
So what is vertical line test? Anybody?
So simply we have to draw a vertical line parallel to y-axis and check the intersection point.
So I'm writing it formally. If we draw a vertical line on the graph, observe here you have to draw on the graph of the given function, then it never crosses the graph in more than one point. So vertical line test is actually the opposite of this. I am saying you have a graph of a function, okay, then if you will draw any vertical line on the graph of that function, then it must not cut more than one point. So what is the vice versa of that? If it is cutting more than one point, that means it will not be a graph of a function. Any doubt? Anyone? Okay, so if you will draw a line here, at how much point is it is cutting the given this equation, or you can say given this figure,
2 points, sir.
this one and this one. So that means it will not be a graph of what about this one, B? What about this one? Tell me.
It is a function, sir.
It is a function of.
Why?
It will pass vertical line test.
Okay. Do anyone feel it is not a function? See, it has three subparts. One is the straight line. If you will draw a line, vertical line here, it is only cutting only one point. If you draw it here, again 1 point, again 1 point. So that means it is a graph of a function. Next, is it a graph of a function?
No, sir.
Why?
No, sir.
This vertical line
It
cutting
cuts 2 points at a time.
3 point. In fact,
3 points.
you need only one line. See, one can also say that you are drawing this line and it is cutting only one point. No, you need it for all. If it is cutting at one point, then it should be every vertical line, follow for every vertical line. But you have two possibility. One vertical line is cutting only at one point and another vertical line only cutting at 3 points. So that means you got one counter example. If something has to be follow, then it should follow for all. If it is not following for all, then you cannot guarantee. So here you are having one vertical line that is cutting at 3 points. That means this is not a graph of a function. Understood? D part. I am giving you some ellipse. See, it is the representation figure of an equation, but still it is not a,
Function.
so not a graph of a function. Clear to everybody?
Yes, sir.
Okay. Next is graph the following equations and explain why it is not a or in fact not explain, check whether it is a graph of function or not. So first equation I'm giving you, mod y equal to x. Draw the graph of this equation, then tell me whether it is a graph of a function or not.
That it is a graph of a
Yes, sir.
It is graph of a function.
Yes.
Very good. Anyone other else? आंसर गलत है. What is the graph of this mod y equal to x?
Minus.
No, sir, it is not a graph of a function.
No. Now it is a graph of a function. Now you tell me how it is not a graph, how it is a graph of a function. Hariom.
Sir, if you draw the graph of this function, we will have
Only positive values of x.
yes.
So for positive values of x, if you will see, either y can be equal to x or minus y can be equal to x. If y is positive, if y is negative. In both the cases, your x has to be positive. So what is y equal to x? For positive x I am saying. And what is y equal to minus x? This is the graph of this equation. Now draw a line. At how much point it is cutting?
2 points.
So this is not a Next, this time you should draw properly. Whether it is a graph of a function or not, write in the chat box. So how you can draw this graph? Archit, I think you have done it.
Sir, we will write it as x plus y equals to 1 and x plus y equals to minus 1.
Okay.
And sir, draw both are straight lines. We will draw them separately.
So x equal to 1 is this one, and minus 1 will be, both are minus 1, this region. So these are parallel lines. Me drawing the sense. So which region, or you can say these are both the lines. Archit.
Yes, sir.
So if you will draw a vertical line,
It will cut at 2 point.
then again so now I'm going to introduce a new notation or new notion that you have not covered in the class, that is composition of functions. So if f and g are two functions, then the composition function, it is denoted by FOG, that is F circle G is defined by F composition G is also a function F at G of X. And again, next is the domain of F of G is all those points domain of G for which Gx lies in the domain of F. Can anybody tell me the meaning of this line? The above one is obviously you can easily understand that if you combine the composition FOG at X apply, then it must be applied at first X, then it will be applied to F. What is the meaning of this?
Sir, it means that the range of G will must lie in the domain of F.
Good. So this means the we collect all those X from R such that range of G must lie in domain so we are collecting only those points for which this range belongs to this domain of F. Reason, definition, recall the definition of a function. A function is defined, collection or domain of function is the collection of all those points for which it is well defined. Suppose you have some number x for which your gx does not belongs to the domain of F. Then can you think this FOG is well defined? For example, I am giving you fx is equal to under root x and gx is equal to some, you can say, minus mod x. So g at 1 will be g at 1 will be
-1.
-1.
what will be FOG at 1 if you try to calculate? It will be f at g at 1, correct? So that means what is g of 1? -1. So what is f at -1? Under root -1. So will it define?
No, sir.
No. Why? What is the reason?
Sir, it is an imaginary number,
Domain of f is what?
real number.
Again, the same mistake. What is the domain of f?
Non-negative real number.
Non-negative real
Non-negative
number.
real number.
And what is the range of x? G? What is the
Real
range?
number.
Non-positive real number.
Real number.
Non-positive real number minus mod x.
Yes, sir.
So here range of G is containing in domain of F. Tell me.
No, it's not.
So if it is not containing in F, that is why your F composition G is not defined here. That is why I have written this domain of F of G is defined only when the range of G must contain in the domain of F. Understood the importance of this?
Yes, sir.
Okay. So let me wrote a question over this composition. If fx is under root x, now tell me what is the domain of fx? Pallavi.
No negative real number.
Negative real numbers.
Okay. X plus 1, find f composition g of x, and also tell me when this composition is well defined. Do it. Tell me, first of all, tell me how many composition here can be possible with these two functions. I mean, FOG, GOF, how many can be possible?
Two,
Sorry?
two compositions, FOG and GOF.
And FOF can also be possible, na? G of G is also
Yes.
possible. So, there are 4 possible combinations. So, first of all, calculate this, then we will discuss the others one also. Did anyone got the composition?
Sir, under root x plus 1.
Correct. And what is its valid domain for which it is defined?
Sir, x will be greater than or equal to -1.
So before doing this composition, what you should check, domain of f is 0 to infinity and range of g is whole real number. Correct? Correct.
Yes, sir.
Yes, sir.
So when range of g will contain in the domain of, for which values? Why
Sir,
I'm
GOF.
Since we want to do the composition of GOF, so it is valid only for those domain elements for which this range is containing this. So this is valid for only those points for which this is lying in this. Okay, so if you will do the composition, this will be f g of x. What is g of x? When g apply at x, what is g of x will give you?
Under root x plus 1.
I am, first of all, here the question. I don't want answer. I want you explain the steps. What is g of x? X plus 1, correct?
Yes, sir.
So what, when fx, when you substitute x, it will give you input. When you give input x to f function, then it will give you under root x. When you put x plus 1, what will it will give you? Under root x plus 1. What you are just doing, you are just replacing x by x plus 1. So this is your composition. And what is the domain of this that is valid for this composition? What is the domain of this f of g? What is the domain for which it is valid?
Sir, x plus 1 will be non-negative.
Minus 1 to, it is correct? Any doubt? Now do g of f and tell me its domain also. Quickly. Okay, do with me. Here. G at fx. What is fx? Tell me. What is fx?
Under root x.
Root x.
So gx is x plus 1. Then g of under root x will be
Root x.
Root x plus 1.
1. What will be the domain? Correct? Now the third one. G composition G. G of gx. That means g of under root x. Again, under root of under root x. That means x to the power 1 by 4. What will be the domain of g of g? I don't think so it is that much hard.
Zero to infinite, zero closed.
No one is focusing. What is g of x? What is g of x here?
Sir, x plus 1.
Then how did
Yeah.
I do this?
Yeah. X plus 1, and this will give you x plus 1 plus,
Plus 1.
so it will be x
X plus
plus,
2.
and the domain will be whole
Real
real
number.
number. Now for this one, this will be f of under root x, under root of under root x, that is x to the power 1 by 4, and domain of this f of f will be, correct? Now the last thing, what is even function? Anyone? A function f is said to be an even function if f of minus x is equal to fx for all x in the domain of f. Okay, and if I would say what is then odd function? When it will give you minus of fx. Any doubt in the definition?
No, sir.
So let me just tell you with some graph, and this will be the last for this class. So example is fx equal to x square. What you have to do? Just substitute minus x in place of x. This will be minus x whole square. This will be x square. This will be fx. So that means f is an
Even function.
even and you will draw the graph of this one. So what is the meaning of here some x 1 and here it is minus 1? So this is positive and this is also positive. So it is symmetric about, tell me, symmetric about
y-axis.
y-axis. Good. Now what about this one? Suppose fx equal to x cube. F of minus x will be minus x whole cube, which will give you minus x cube, that is minus of fx. So that means f
It is
is an odd
odd.
function. And what is the graph of this f? Like this. So it is symmetric about origin.
Origin.
If you will see from the origin, it will go like this and it will go like this. In the same way, it is moving. So quickly,
Sir, how we define symmetricity about a point like you said now it is symmetric about origin. How we say that?
because see, when you will put one point here, one point here, from the origin, it has the same distance. Observe here.
Yes, sir.
So in the sense of origin, I am saying it is moving somewhat upward and somewhat downward. That is why I am saying in the origin rather than any axis. Here what is happening? It is along the axis, if you will observe here. The same distance from here, the same distance from here. Okay. So which of the following are even or odd functions? So the first one is g of t is equal to 1 by t minus 1, or neither. It is not necessary that a function is even, that it has to be odd. It cannot be even, it cannot be odd. So I'm giving you 4 functions. Quickly tell me out of these which are even, which are odd, and if you need explanation then also let me know, because it is not that much tough. Come on, tell me quickly. First one is even function or odd function, or neither? Are you doing it? Anyone?
It is
First is, I
neither,
guess,
sir.
odd function.
No, sir, it is neither.
Who is saying it is an odd function? I think Meg.
Yeah.
Neither. Meg, it is an odd
Yes.
function.
I guess so.
Okay. So you don't need to guess. You just need to put minus t in place of t, and you will get minus t minus 1, and from here minus 1 by t plus 1. Do you see any comparison between this one and g of t?
Yeah, like the minus signs have been replaced.
No, replace na. So you cannot compare both the things na. You cannot say g it is
Yeah.
minus of gt or plus of gt. You cannot say.
Yeah.
So that
Yes.
means
It's no,
neither.
neither. True.
Now similarly h of minus u will be, you will tell me.
Even,
Wait, Pallavi, wait.
oh, sorry, sir.
Yeah. Meg, tell me. Put minus
Yeah.
u. What will you get?
Minus um
What mod? What will do mod do?
mod 2 minus 2 or plus 2.
It will remain the same.
Yeah, it will remain this. Oh
H of
yeah.
u.
Yes. Sorry, my mistake.
So it is an even
Even
function.
function. Yes, got
Even
it.
matlab even function. Don't consider it as a number.
Yeah.
Now tell me about this one. F of minus v. That means minus v whole square minus 1. It will give you
Odd function.
Odd
Odd
function.
function.
odd function. Good. So it is an
Odd
odd
function.
function. Now no one will do, only Mehak you will do. T of minus z. Tell me what will be the output?
Minus z the whole square plus minus z. So then it will be minus
Minus
z. Yes.
minus z square is z square.
Z square. Yes.
Z
So
square
it will
minus
be
z.
equal.
Neither. Understood?
Got it. Understood, sir.
So what we have done today? We have first of all learned about the supremum infimum. Then after that, tell me. Then we have done the decimal representation. Then we have deal with the intervals, absolute values, and after that functions, composition of functions, and at last what is even and odd functions. Okay.
Yes, sir.
So do you have any doubt? Anyone? If not, then thank you for joining. We'll meet on next Tuesday in the week 2 problem solving session, same time. Okay.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.